you are dealing with a staphylococcus. You are dealing with a staphylococcus, and most times you are looking for the beta hemolysis, and that will narrow down your therapy, whether you just need to go for a more advanced treatment protocol, or it helps you to tailor your treatment according to what your microorganism is from the isolation over there. So, yes.
Sorry. I think I'm seeing that some people are saying they can't hear you. I just want to cross-check whether, just type in the chat if you can't hear anything at all.
Okay.
I've seen some comments by 3 people, so I'm just concerned whether it's across everyone.
Can you hear me yourself?
Yes, I can.
Okay.
Yeah. So please, if you can't hear Dr. Kamagi, kindly just, if you can hear, just kindly text in the chat yes. If you can't, kindly just text no. Then we can resolve it from this end.
As the moderator, I'm going to say what I used to see in the U.S. presidential debates, where somebody says, "Oh, stop the time for me." So, all right,
okay, so
we are in the election mode. So stop the time for me. Now you can start it again.
Thank you so much, Dr. Kamagi. It's based on the responses is that majority can hear. So I will request that the members who cannot hear Dr. Kamagi, kindly check your audio. There is a button on settings for your audio. So you need to enable the speaker audio from your computer or the device that you are using so that you can be able to hear. If you're having difficulty, just say chat me directly so that you can resolve that. So back to you, Dr. Kamagi, and proceed.
Thank you. Now, as I finish up the aspect of regulatory aspects of this discussion, we talked of direct microscopic somatic cell count, and the other way of determining somatic cell count is by use of a Combi machine. A Combi machine is just a big name, but it looks like the one back to machine that I showed you in the previous webinar. If you missed it, it's on YouTube, it's somewhere. Momanyi, get in touch with Momanyi, and you will see how a Bactoscan works. Now, a Bactoscan simply takes a sample of milk, runs it through, and shoots out the results in 9 minutes. And it simply mimics the entire procedure used in a standard plate count. It does the incubation within the system and shoots it through a laser and counts the bacteria. And in 9 minutes, you can have your bacterial count shot on the screen. A Combi machine produced by Force. Force is one of the companies that produces a lot of equipment used in analysis in the dairy sector. There is a machine called Combi. Combi works exactly like the Bacto, twice as fast. A Bacto will run 150 samples an hour. A Combi will do 300 samples. And what a Combi will do is it will determine the butterfat, the protein, the lactose, total solids, and in addition, it does somatic cell count at the end. So the Combi machine is exactly like the Bacto. The only difference is one is specifically for bacteria, which is the Bactoscan, and then Combi does a combination of components, that is butterfat, protein, lactose, and total solids, and includes the somatic cell count. Now, I gave a brief example of how a premium program will look like. And the other important bit was how to test for drugs in milk. The first one is the Delvo test. A Delvo test can be in 2 ways. It comes in a block like what you can see in the middle, or it comes in simple ampules. As you can see, each one of them comes with a tablet container. They are very tiny tablets. So what you do if you want to test a series of milk samples, now you open this, get the tablet, put in each of these wells, and then you sample using a pipette that I showed you. You agitate the milk 25 times, and then you put a sample of around 250 microliters in here, and then you incubate it at 64 degrees Celsius, and you wait for 2.5 hours. And when you come back, you get your result. Now the results look like this. If it is negative, you'll find the bottom part. Of course, you can flip this one around. You'll find the bottom part yellow. It will be yellow as the foil cover over here. That tells you yellow in a Delvo test means not found. I said when you're doing an antibiotic test, you never use the word negative. The correct term you use is not found. I'll repeat that. Because we are going to be the ambassadors out there, we have to get the right terminology. Terminology matters in science. When you are reporting antibiotic testing, you never report it in terms of positive, negative. When it is negative, you simply say not found. There's nothing like negative when you're reporting an antibiotic test. Now, for a positive, it will be purple, just like you see on your right-hand side. It will remain purple just like that. And that will be positive. So positive can be reported as positive, and negative cannot be reported as a negative, and negative is only reported as not found. The next way of determining antibiotics in milk samples is by use of a SNAP method. Now, the SNAP kits are produced by a company which is common in Kenya, IDEX. It comes with 2 of these snaps, we call them snaps, and a block, a heating block that has a thermometer. This one here should be around 64 plus or minus 2 degrees Celsius. So that's the reason why you put that. And because this was a regulatory lab, we had to maintain it there just to prove in case we had federal inspectors, they will come in and want to make sure that this block is actually maintained at around 64. The only way you can do that is by sticking a thermometer in that hole. Now, the right-hand side has the SNAP kits. And as you can see, the way to place a SNAP kit is it has this ridged edge over here. This ridged edge, they made them with the assumption that most people are right-handed, and therefore the ridged edge is always facing your right-hand side. Now, when you do that, when you want to put a sample in here, what you need to do is you take this and place it on the block. It doesn't matter which side you put it. If it is 1 sample, if it is 2 samples, you can put 2 samples at a time. So they start warming up. They also come with a small tube that goes inside here. So all this mechanism heats the SNAP at the same time it heats the sample. So you put the tube in here, it starts to warm up. Then you put in around 450 microliters of milk. You can buy a pipette to give you 450 microliters. You put in there and let it stay for 5 minutes. Once it stays for 5 minutes, use a timer to do that. And timing in SNAP is important. You come and pour that milk sample in this well over here. And what you do is you wait to see the capillary milk moving by capillary action. So this part over here, this small pot over here is called the activation cycle. So as milk moves in, you'll start seeing this part, which is the activation cycle, starts getting covered by the milk. According to the regulation, the very moment it starts covering the activation cycle, you need to press the ridged edge over here. You need to press that, press it hard all the way. And when you press it, you time for 4 minutes, then you can read the results. This is how you read the results. When you have the control side is always your right side. So if you have this other side lighter than the sample side, which is the left side, then you know you are dealing with a negative. But if you have the control side, which is the right-hand dot over here, darker than the left-hand side, then you know you are dealing with a positive. And I'll review what I just said. If you see the right-hand side lighter than the left-hand side, then I kind of used a wrong word. You say not found, not negative. But if it is darker, then you know it is positive. So that's a little bit of this. The other method that you can use at the plants, in milk processing plants, we call it Appendix N testing. You use what is called a CHAM method. Right now where I work, we use the CHAM method. And what you do is it tests antibiotics right as soon as that milk comes into the plant on the truck. And it gives you the antibiotic results in 3 minutes. Excuse me. So that's a little bit of the summary of what I did last time. Today, my focus, and I want to run through this, is going to be the farm milking system. And why is the farm milking system important? We can't talk of milk quality without determining how we are harvesting this milk from the cow. It is going to be a little bit of what might seem to some of you as unnecessary physics and engineering, but trust me, it is not. If I know it as a veterinarian, anybody there should be able to know it, because it is not that. There's no point talking about milking and talking about milk if you don't know how these machines operate. I will break my lecture today in 3 parts. We will look at the design and the operation of the milking system. Then we will go into CIP wash system. CIP in full is an abbreviation for clean in place. In other words, you are cleaning without disassembling the components of the milking system. Then we will get finally to the wash system analysis. How are we going, if you go to a farm and a farmer tells you that I'm doing everything right, but my bacteria counts and probably my somatic cell counts are right. And then you rule out bacteria and you rule out somatic cell count, that leaves you with one thing. It could be coming out of the milkers, it could be from other sources, but most times, 9 out of 10 times, it is from the milking system, be it the design or the functioning operation of it. So that's what I will concentrate on. And just to start us, of the milking system design has 3 main parts. It has the vacuum system, it has the cooling system, and it has the clean in place wash system. Now, I'll take you through how a vacuum system works. Now, the reason why I'm going through this is I went into management of the farms with zero knowledge about how these systems work. And it took me a lot of time, a lot of training, especially by the De Laval company that installs a lot of milk equipment to train me on how these things work. And I did see them in very simple forms, in very complex forms. And therefore, I think I have a pretty much good grasp and understanding of how these systems work. And therefore, I sat down and tried to break it down to the simplest way in order not to confuse anybody that is hearing this for the very first time. So I'm big on diagrams, and that's what I'm going to use. So I want to start by showing us what the vacuum system of a milk system looks like. At the middle part, that's where I want to start. The vacuum, as you know, the milking of a cow requires a vacuum if you're using a machine. Unless you're milking that cow using your hand where you can squeeze the teat, there is no other way of evacuating milk from the teat of a cow without the use of a vacuum. So that vacuum has to come from somewhere. And we use a machine known as a vacuum pump. What it does is it runs and generates vacuum. Now that vacuum is run into the lines, and I will take us step by step as to how that vacuum ends up at the teat of the cow. And towards the very end of this talk, we will look at how vacuum can affect mastitis and how it can affect somatic cell count in very, very significant ways. Now, this vacuum pump over here, like I said, generates vacuum. Now, How does it work? It is controlled by what we call a variable frequency drive. That's a big name. You don't have to cram any of these words, but this is what drives this machine. Variable frequency simply means if there is demand for more vacuum, this drive will instruct, for lack of a better word, will pass a signal to the vacuum pump to ramp up and produce more vacuum. That will happen many times when, say, you are milking 3 cows and all of a sudden you start milking 10 cows. That is a much higher demand of vacuum, and therefore this drive will pass a signal to the vacuum pump to ramp up. Oh my God, this thing is so sensitive. Did I mess it up? Okay, just give me a moment so that I figure out where I was, guys. Just a minute. Okay, sorry for that. So there will be a signal sent to the vacuum pump if the vacuum produced is low to ramp up vacuum production, and that circulates in sort of a loop. Now, attached to the loop of vacuum that is already circulating produced by the pump is what we call the pulsator. And the easiest way to describe a pulsator to you guys is when you're milking a cow, it is, if you're using 2 hands to milk a cow, it is left, right, left, right. Now, if you're using a vacuum, you can't just put a vacuum and have everything come out at the same time. So the only way to mimic what you do with your hands, like the left, right, is by introducing what is called a pulsator. It pulsates so that it milks one teat at a time in a rhythmic function. So it is attached to the vacuum. The only thing it does is it then mimics the actual hand milking by pulsating so that not all the teats are milked at the same time. So we have a pump. A pump is regulated by a drive which controls how much vacuum goes into the line. If there is less vacuum, then the drive sends a signal for the vacuum pump to ramp low on its production of vacuum. If there is higher demand, then there is a higher signal sent in here and there is more vacuum. The normal vacuum that is required at the teat end of a cow is around 13.7 to 14. How do I know that? Because I was a milk inspector. I could go out there and one of the things that I will inspect is how much vacuum are we running into the teat of a cow. So that is very, very important. Around 13.7 millimeters of mercury is the amount of vacuum pressure that you need at the teat. If you increase that higher, then you start damaging the teat ends. You start having elements of higher somatic cell count. So that is important. Let me look at the next slide. Oh my God. I'm messed up today. I'm a mess today. Huh? Sorry. Okay. The second part of it, remember I talked of the vacuum system, and the second component of a milking system is the cooling aspect of it. And it is very, very simple. The milking system is fast. If you can ride a bicycle, you should be able to understand how this thing works. That's how I tell it to people whenever I explain. If you can ride a bike, that is just how simple this system works. We've already seen the vacuum. We're already running this vacuum. We don't know where that vacuum is ending. At that point, we have just attached to the vacuum line. Now that pulsator comes in and attaches onto the claw. These 4 things, probably those that have seen milking systems, you've seen, these are the, we call them the claws. They're the ones that attach onto each teat. There are several aspects of the claw. The bottom part of it is where milk comes out. But because this diagram is small, we have these 2 dots over here. That's where the lines from the pulsator, you see the pulsator has two outlets over here. They're the vacuum lines that come out, and then they come and attach to this. So that controls the rhythm. When it does that, vacuum sucks milk from the teat of a cow, and that milk is dispelled through this hose. The first place where that milk goes into is a small tank. That tank is referred to as a receival. The reason why it's called a receival is because of exactly that. It is receiving all the milk right from the cow. Once it is received, this has a pump underneath it. Depending on the size of the farm, some farms will just have this and a small pump. If it is a big, massive farm like the one where I was the last time, it's a 10,000 cow farm, you'll have a much bigger pump. So what it does is that it pumps the milk that was already here, because once you collect it, it has to be pumped somewhere. It is pumped, and again, just like this drive over here that works on demand, it also is a variable frequency drive pump. If there is more milk inside this tank, it ramps up its functions and therefore pumps more milk. If there is low milk, then it ramps down its functions so that you don't burn out the pump. That milk then passes through what we call a plate cooler. And I like to illustrate how a plate cooler works. This is how it works. Milk comes in one direction and water comes in the opposite direction. A plate cooler will function in the same way, whether you are in an industry, whether you put one in a trailer, whether you put one at the farm. The same physics. Milk goes in one direction and water comes in the opposite direction. And normally the way they are designed is, if milk inlet is on the bottom, they'll make sure that the water inlet that comes in from the opposite direction is on the top. The reason is you want to increase the surface area in which milk, what is going on here? You want to increase the surface area in which milk is in contact with the water. Now, they don't come in contact like direct contact. That's why it's called a plate. On one side of the plate is the milk, on the other side is the water. That's all you need to do. So the milk comes out of the body of a cow at body temperature of the cow, and you have water over here that interfaces with that milk and separated by a plate. So they don't come in direct contact. So that cold water picks up the heat that is in the milk, and by the time the milk comes out into the tank, it has been cooled down. It's a very fascinating process in such a way that when milk comes in, probably at around 50 degrees Celsius, this will knock it down to a very, very considerable temperature. I said Celsius, but I meant Fahrenheit. So that's what happens over there. Now, where does this water come from? There is a box over here or a tank known as the chiller. And what happens at the chiller is from basic high school physics, water will always freeze at between 0 to 4 degrees Celsius. So what happens in the chiller is you put glycol, and when you put glycol, propylene glycol, when you put propylene glycol in here, it lowers the melting point of the water. So if that water was to freeze at, say, 2 degrees Celsius, it probably will freeze at -7 or -8. That way, when you're passing that water in here, it's very cold, it is not frozen, and when it interfaces with the milk, it takes as much heat from the milk as possible, and therefore that increases the efficiency. So the efficiency of the plate cooler basically depends on the temperature of the water that comes in from the chiller. So this is a loop on one side, as you can see, and the milk is a loop on the other side. Once it goes through the chiller, comes out into the tank. This chiller is also attached to the compressors. Compressors work pretty much the same way as the radiator of a car. Simply, blows the hot air out, and that necessitates the cooling or maintains the cooling of the chiller. So that is how it works for the design of a milking system. And then the next part of our talk today is going to be, I wish I had a better way of doing this, but guys, we just bear with me. So we started with the vacuum, then we came into the cooling system. Then I want to talk about CIP wash. CIP in full means clean in place. And what that means is a milk machine system is not designed to be taken apart, to be washed using a brush and soap. You need to be able to just activate a wash signal, and it's supposed to get into the wash mode right away. So just to start us off, I want us to agree on a few things. One, that a milking system is not designed for washing, but it is designed to prevent slugging during the transfer of milk. As a milk inspector, when I went out to inspect milk, one of the things that I do when I look at a milk system is how the lines are running. If you find a line in any milk system that gives you a potential of milk sitting on the line, there could be a dip, it could be a warping, whatever it is, that is a debit right away. Milk should not be at any one particular point trying to sit on the line. The milking system should be designed in such a way that there is no pooling of milk at any particular point. Now, analyzing or monitoring of a washing system is much more than just checking the water temperature and titrating chemicals, and I will get into the details of that. So what are the aspects of the wash system? There are three main aspects of the wash system. We have the physical part. So today, I want to make this as simple as I can. As I was preparing my slides, a thought came through my mind. How can this be simplified without bogging you people up with a lot of complexities? And I remembered something about the COVID. You know, we are all aware of how COVID has affected the world. How they tell us to wash our hands is the same exact way a milking system works. In other words, they will tell you when you go into a sink, wet your hands first. Once you've wetted your hands, then apply a detergent. And the assumption is that detergent is going to disrupt the membrane of the virus. Then you can sanitize. That is what they do. And that is the same exact way a wash system works. It has a physical component of it, and it has a chemical component of it. Then there is the temperature component, and the temperature part is considered to be the cause of most wash failures. So to have a clean in place requirement, you have to have a wash cycle that has a pre-rinse, a wash, an acid, and a sanitize, and I will get into the details of that. And again, the most important aspects of it are time, the temperature, the chemical balance, volume, velocity, and drainage. But now, let us go through step-by-step process of the washing of a milking system. The first step is like wetting your hands. In the CIP steps, we call it the pre-rinse. It normally lasts 5 minutes. And by the way, all the steps of a wash system last 5 minutes, except the second step, which is the caustic wash, and I will explain to you why. So you start by wetting the surface. Just like, remember, when you go to wash your hands in a sink, the first thing you do is to wet your hands. That helps in removing residue and, of course, wetting the surface of the milking equipment. Then there is what we call the caustic wash. Other places, you'll find it just referred to as the detergent wash. It is the longest cycle, and what it does after you've wetted the surfaces, then the caustic wash, you use soap, and it simply softens the fats. It increases the pH because soap is normally at a much higher pH. So it will raise the pH, it's mostly alkaline. So, and that's why it's called the caustic wash, because it is a wash that has a caustic agent in it, and that caustic agent most times is a detergent. And the other important part of the wash, of the caustic wash, is the temperature of the water. And whenever you have a problem in a washing system, the first thing you want to look at is at what temperature is that water getting into that system. Normally, it's supposed to start at around 160 degrees Celsius. And then at the time the cycle for the wash ends, it's supposed to be draining at around 120. That is something to remember. Most times you'll go to a farm and you look at the hot water system and they're running at probably 80 and the thing is draining at probably 40. And you tell them that is number one cause of your bacterial count, because then you are not removing some of the fat, and times without count, you'll end up with buildup in the lines. And that's a very, very major cause of Jesus Christ. I don't know what I'm doing. Okay, I'll leave it at that. So caustic wash, this third bit of it, now that you have used soap in the system and you've raised the pH, from chemistry, you cannot leave that, that soap in the line. You have to neutralize it and you use an acid rinse. So you start with a pre-rinse, you use the caustic wash, the soap, then you use an acid rinse. Then finally, after you have washed this, the acid rinse helps in lowering the pH, which you increased in step 2. And it also helps remove what we call milk stones. And again, common sense tells us that when you put an acid into a base, you're going to neutralize it. So that's the third reason, fourth reason as to why you use an acid to neutralize the soap. 4, you have already washed your hand. What do? You go ahead and sanitize. And that's exactly what you do. You've already washed the system. So what do? You sanitize. And the sanitizing process, just like in our coronavirus protocol, that is the process that actually helps in the killing of the microbe. And you use what we call a chlorine compound. Normally you run a chlorine compound right through the lines. Now the requirement is, I've seen farms that run a complete CIP system and they're like, you know what, we are going on a vacation and we are not gonna run this machine until tomorrow afternoon. Anytime you do a CIP wash, you only have 24 hours to let it sit down. If you have not used it in 24 hours, you have to, whether you've used it or not, you have to rewash it again. That's a very important part to remember. So how can we analyze or how can we inspect a wash system? Now, wash failures, just to start us off, they are best detected by observing the CIP wash. The best way to do anything. And what I used to tell my interns, be they veterinarians or students, whenever they came to intern under me at the farm, I would simply tell them to diagnose a cow, take time, take a step back and just watch that animal. Just watch that animal. You are not gonna die. Just watch how she behaves. Because we are very quick to go in with a syringe and a bottle without taking time to understand what is going. Take a step back, just observe. And at the end of the day, when you shove your hand inside the rectum or when you use your stethoscope, you already have a brief, complete picture of what we're talking about. So wash systems are observed, and that's the best way to detect any issues with the CIP wash failures. Common failures that lead to an increase in bacterial counts will include, number 1, problems with the vacuum and the pulsation. If you don't have the right vacuum pressure at the teat end, remember I said the correct vacuum pressure should be not anything under 13.5 millimeters of mercury. If you have anything lower than that, then you are most likely helping to milk that cow, but chances are you are not getting all the milk out of the udder of that cow. What does that mean? When you have reserve milk or reserve milk left in the udder, you are predisposing that cow to incidences of mastitis. Not to mention that you will have your cows not peaking at the right time, because then you start having a negative feedback on lactogenesis, and just because of the pressure from the udder, and you end up with very, very good cows that eventually don't peak in the milk production. When I was in management of farms, that's one thing I was very, very hard on my employees on. You find employees that will just attach a milking machine and they don't, because they're in a hurry, they don't allow this cow to completely milk. And therefore you end up with premium cows not getting completely milked, and cows are not peaking, and without any hesitation, you end up with cows that are just generally getting into their dry periods while not pregnant. You cannot allow that. So for health reasons, for mastitis reasons, vacuum and pulsation is an important thing. The second part of failure in a milk system has to do with the cooling. Remember the slide that we went through about the cooling. The cooling system is necessitated by the efficiency of the plate cooler. If you don't have the right cold water going in on one side, then that milk is not going to come out, because most tanks are not designed with a cooling system. They are only designed to be compartments to hold an already cold milk. So if that milk is coming in to be stored when it's already warm or not cold enough, chances are the very moment it gets into a tank, and most tanks are situated outside the building, it starts warming up. Now, there is a given temperature that milk has to be in order to be picked up from a farm. It has to be between 0 and 4.5, anything 4.5 degrees Celsius. Anything above that cannot be taken out. And that's a very, very common thing as an inspector. When you go out and you find that somebody's pumping milk and that milk is above 4.5, the only thing you can tell them is open the nozzle and let that milk go down the drain right there. It is a loss, but you cannot ship milk that is over 4.5 degrees Celsius. The third component is what we call the liner slips. The cloths that I showed you that attach onto the teats, they have a rubber lining around them. Those rubber linings are known as the liner slips. Sometimes they get overused and they don't seal on the teeth so well, and you end up with what we call quacking. When that happens, you end up with, like somebody is snoring. That happens whenever a cow is milked using liners that are damaged. So what do? You have always to make sure that your liners are well serviced and they're not overused to avoid the liner slips. Fourth is the chemical component and the chemical pump. Remember to put the detergent in the water so that you can circulate it, or to put the acid in the washing system. It does not do that by gravity. There has to be a pump. So that pump sometimes fails. And most times when you start having bacterial counts increase in milk or in the lines when you do a swab, what will happen is that when you go and do a titration, you realize that the chemicals coming out, be it the soap or the acid or the chlorine sanitizer, is not at the right amount. And therefore, that is a fourth reason as to why you have a CIP failure. The fifth one is the temperature, and I've talked about that time and again. When you're washing a system, you require to have the right temperature. I told us that the caustic wash needs to start at around 160 degrees Celsius, and by the time it drains, it's supposed to be around 140. If you're not meeting that, then probably you are not eliminating the fat deposits in the line, and that could be a cause of CIP wash failure. There is something we call a trap ball. The first tank that I talked about, when the milk comes out of the cow, it goes into a receive all. That receive all does have a trap mechanism so that when there is too much vacuum, then it stops the milk from coming out of the teat of the cow until you can go and correct the vacuum. We call it a trap. That ball sometimes has a lot of buildup in it, and it has to be inspected every so often. So that is another part, another cause of the CIP failure. And then of course, the plate cooler efficiency, I already mentioned that with regard to the cooling. Number 8, you can have build up in the cloths. When you don't wash so well, you have a lot of build up around the cloth, around the cloths and the pulsator lines. And then milk systems, the way they're designed, they're not continuous. They are connected using connectors. Now, in between those connections, we have rubber gaskets, and those gaskets sometimes wear out, or the seams don't just bind well when you connect them. using connectors, and they need to be inspected so often. And then lastly, you have ineffective controls where something tells the wash system to put in chlorine when it's supposed to be putting in the soap, then you end up with a failure. The last slide before I take in questions, what are some of the uncommon milk system causes of increased bacterial and somatic cell count? There are certain causes that we know, and I will not go into them. Reason being, we already know them. I will go into what is not expected and what we don't generally see. The first one is the deep system. The people, that is not directly a part of the milking system, but you are trying to diagnose what are the causes of your bacteria and higher somatic cell count. The dipping system that you use for your pre-dip before the milking and post-dip after the milking is very important. There are several dips out there. People have used iodine. I live in a place that is perhaps one of the coldest in America, Western New York. And what will happen sometimes, you'll have a dip in a cup in the winter and the thing will freeze. So what you do is you look at your dip, and when you dip a cow and the cow walks out, she has literally ice cream of iodine around the teeth. That only happens in a place like United States where the temperatures get extremely cold in the winter. And therefore, what do they do to solve that? They normally add what we call emollients, just an oil factor into the dipping system, just to make sure that it is blended well into the iodine to avoid freezing. The other factor is poor udder preparation. Now, ideally, to get the best stimulation of the best milk letdown, you need around 90 to 120 seconds of udder stimulation. Many times, especially when you're dealing with many cows or you have an employee that thinks that the best way to go around this is to milk cows quick so that he can go and have a date with a girlfriend, they will not allow this cow to have the best milk letdown by compromising on stimulation. They do it at under 90 seconds, and that cow will milk. By the time that machine comes out, actually that's the time the milk is supposed to be coming out of the cow at its peak. So you end up with cows leaving the parlor wherever they're being milked, having not been completely evacuated of milk from the udder. So stimulation is very, very important. The other aspect of prep is the dip application. There is a reason why people use a dip. It is supposed to be used to dip the teeth. It is not supposed to be used to color the teeth. It is supposed to dip the teeth. Make sure that that teeth end actually ends up inside that, be it iodine or hydrogen peroxide that you're using. And then the other part of the udder prep is the cleaning. Once you apply the pre-dip, you are supposed to clean it off before you can milk that cow. Many times people can use paper towels. Some people can use cloth towels for that. And at times you end up with poor cleaning behavior. And so that teeth ends up not being cleaned. Guess what will happen when you attach a machine to it? All that manure that was on the teeth gets sucked into the system, and hold and behold, what happens is your bacteria count goes high. A very uncommon thing that I've seen time and again is what we call stray voltage. When a milk system is designed, we have lines that, we have electric lines, be it for the lighting system or be it for the operation of the pumps and stuff like that. What happens, and many people don't realize this, imagine if you went to take a short call and the very moment you start, there is a shock system on your feet every day. What happens is that straight away you start having an electric fear because you attach the milking system to an electric shock. Over time, when milk systems have been designed, time and again, because of the earthing of the pumps, because of the earthing of the equipment, you end up with the floor, because the milking floor is normally wet, you end up with electric current flowing on the milk flow. And the very moment a cow walks in, guess what? They don't have shoes. That electric current just gets transmitted right into the body. And you start having this cow going through subtle amounts of electric shock, not enough to kill them, but they are being milked under electrification. Now, this should not happen to anybody. It should not happen to a cow. And that normally happens. Many times I've seen farmers call and they'll tell me, you know what, I've done everything. I've cleaned everything, but my somatic cell count is so high, my milk volume is so low. What happens? The first thing I normally tell them, get an electrician out and do a stray voltage test. Make sure on the milk flow, there is no stray voltage, because if cows are getting shocked, then they start associating the milk pallor with pain. And the other part of that is, I've seen people, even veterinarians, going to give injections during milking. Stop that if you're a veterinarian. Never inject a cow when they are milking. What you're simply doing is, over time, the cows start associating milking with pain. And what that does, it interferes with milk letdown. It is a negative feedback that anybody will go through. If you went somewhere to do something and you associate that with pain every time, then you start developing defense mechanism. And that's the physiology of the cow is just in the same manner. Stray voltage and injections. People will always tell you, yeah, they're already being milked. I can see them, I can see them gastrocnemius. Why not give the penicillin injection? Nope. If you want to inject that cow, let that cow come out of the milking flow and do your injection. Don't even do a vaccination when that cow is being milked, unless you want to compromise on your milk production. I hope that sinks deep. Employee failures, of course, we are all prone to failures. We are not perfect. And somebody can go in and instead of connecting the CAP wash, he forgets to connect that. And what happens is that the entire wash ends up in your tank. I've seen that time and again. That's a common failure. Tank lid gaskets, the tank has a lid. Those lids do have rubber gaskets. They need to be washed every single day. Many times we forget that and you end up with buildup. The second last point, milk transfer hoses. Now, there is a very bad behavior. And as an inspector, I had almost zero tolerance when I walk in a milk house and find a hose that is used to transfer milk into a truck laying on the floor. I don't know if anybody can tell me what that risk is. In fact, in the industry, you can't do it. When you put milk equipment on the floor, and the excuse people will give you is like, oh, I just pumped milk on it, so I'm leaving it there to drain. No, no, no. The highest cause of Listeria monocytogenes on a dairy farm is from a drain into a milk transfer hose. Milk transfer hoses have to be raised above the floor. So when I went out to inspect, the first thing, if I walk into a milk house and I see a milk hose on the floor, right away, that's a 5 debit points right away. There's not even, I don't even waste my time on that because you cannot do that. Number two, they're left open all in the name that, oh, we are gonna leave them there to drain. You have to cap them when not in use. You have to close them so that you don't have exposure. The last bit is what perhaps we are not very, very familiar with. We call it direct openings. When you walk into a milk house, standards of inspection require that the milk house has to have a physical separation from the milking area. In other words, where the tank is has to be completely separated from where the cows are being milked. Most times people put a door over there and find a dog in the milk house, you'll find a cat in the milk house, and the farmer will tell you, you know what, I walked in here and the dog followed me. That's not an excuse. It is your responsibility to take care of your dog. The dog is not meant to be, it's not a milking equipment, and therefore the dog should not be in the milking house, period. Now, the other thing is you find them leaving the door open, claiming that, you know what, it was hot in here and my employees were getting, sweaty, so I left the door open. No, no, no. That is considered a direct opening. into the milk house. You cannot allow that, and it is a potential hazard for contamination or cross-contamination. That ends my webinar for today. And over time, I'll put up together another, if I have some time, put up something with regard to how to inspect a dairy farm, not just the milking system, but a dairy farm. When you go out to inspect a dairy farm, what are the areas that you need to focus on, and how do you score that? Now, ladies and gentlemen, thank you so much for lending me your ear for the last 1 hour. And I want to hand over that to Kevin. One quick thing though, last time, Dr. Momanyi did send me a bunch of questions that you people sent, and I was not able to address. And I want to give this time, if I find some time after the Q&A, to address some of them. I do have them over here. So I'll hand over to Dr. Momanyi, and Dr. if you don't mind, I'll be able to quickly pass through some of these questions. I'll make a statement or two whenever we are done with the Q&A, so that at least we do justice to the people that pose the questions. Once again, thank you so much, guys, and it was my pleasure to have this discussion with you.
Thank you so much, Dr. Kamagi. So now it's back to you, the attendees. If you have a question, kindly just raise your hand. I'll unmute you, and then you'll be able to ask your question. Okay, so we have a Dr. Rolex George. So I'll unmute you, and then you'll be able to ask your question.
Thank you so much, Dr. Kamagi, for a very informative session. And at least we are able to understand some of the aspects of dairy farming in a westernized world. Now, looking at the smallholder systems in Africa, given that this is what we do on a day-to-day basis, where we have farmers owning very little herds of cattle, and most of their farming system are not mechanized or modernized in a way that production is limited to what they are able to do in terms of the returns they get in the production of milk or the sales. Now, the tests that you talked about, when you're looking the SCC, somatic cell count, are there rapid tests that can be able to be in terms of equipments or tests that can be easily done at the farm level or at the milk collection center or bulking group level? And then second question, on the various countries that I've worked in Africa, especially dealing with dairy production, I've noted that most of them have limited their tests, milk testing, to testing for water, testing for sourness to milk, and then testing for soda. These particular limitations in terms of testing, do they really affect importation and exportation of milk by these particular countries or these particular dairy farms? Thank you.
Oh, thank you, Rolex. Great friend of mine. I'll start with your first question. Are there rapid tests for somatic cell count? Rapid will be relative. Remember when I was going through my slide number 22, I think, I talked about a machine known as the Combi. Now, the Combi can run several somatic cell count samples and produce the results in 4 minutes per sample. Now, the Combi machine is extremely expensive. At the last place where I worked, when we bought one, it went for $250,000 US. Not so many farms have that amount of money. Not so many milk co-ops, especially in our developing world, have that kind of money to, put in a milking system. So then, what does that leave us with? It leaves us with use of what we call direct microscopic somatic cell count. And what that entails is, I don't expect the farmer to be able to determine their own somatic cell count. This is a little bit too technical. You have to use a microscope to do that. So what it all entails is you stain. There is a specific way of staining a milk sample to read it under a microscope. The first thing you do, you get a slide, and you get around 250 microliters of the milk, and you put on the slide. You let it stay and set in under heat. Once that happens, and the heat should be around 40 to 45 degrees Fahrenheit. Once it has set in, then you put it inside a stain. The most current stain used, and I know it is cheap, you can get it anywhere. The most current stain that is used, most popular one, is what we call the LW stain. If you don't have the LW stain, you use xylene. Now you put that milk slide that has just been dried, you put the milk sample in, you put it inside xylene for 2 minutes. Take it out, let it dry. Once it dries, pass it through 3 changes of water. In other words, you want to get off excess dye, xylene dye or LW stain off. Then once that stain dries, or once that slide dries, take it under microscope. And this is where experience comes in. You have to be able to know what a somatic cell count looks like. So you look under microscope, and you should be able to count how many of those somatic cell counts. So direct microscopy is the easiest way to do it. There is no other rapid way of doing it. Your second question with regard to the tests. Rolex, what was the context again? I kind of lost my trail of thought. Hello?
Let me try and unmute him.
Okay, yeah, what was the second question with regards to what was the question again?
I'm saying on most of the African countries that I've worked with, especially on the smallholder dairy systems, when you look at the tests that they are limited to doing, most of them are limited to doing tests regarding to water content in milk, sourness of milk, and the soda in milk. You realize that a good number of them never concentrate on the issues of antibiotics in milk, and also they never concentrate on the issue of the somatic cell count in milk. So the milk that is consumed, mostly the pasteurized milk, has got a lot of questions on what is the content and things like that. Now, my question is, does this really affect the exportation, the import and exportation of milk by these particular countries?
Great. Now, importation and exportation of milk is a more stringent, and that's the reason why I focus this discussion primarily on the regulatory aspect. Because to talk about imports and exports, we have to regulate our industry. No country will allow you to export a product into their system without ensuring that that product is coming from a well-regulated culture, a well-regulated industry. And that's the reason why I focused this webinar on how are we going to be the milk producing country of the 21st century. And by that, I mean, are we able, can we authentically say the milk we produced in Kiambu today can get inside a ship or whatever it is and go to Britain without any question? The answer to that, as you all know it right now, is no. Why? Because we don't test for what the international markets look for. The international markets look for 3 main things. They look for bacteria, they look for somatic cell count, and the biggest thing right now is antimicrobial resistance, and therefore they look for antibiotics. Now, organoleptic tests are important. They are important, but they are not key for the importation. I'll repeat. Organoleptic tests are important, like the taste, the sourness, freeze points for the milk. Those are important, but they are not key to the importation. For the importation reasons, we have to have a standardized testing form bacteria, and we have to prove with records. We have to have a standardized criteria for somatic cell count testing, and we have to prove with records, and we have to get a hold of our antibiotic residue testing. If we don't do that, we might as well just milk the cow and consume that milk, or better still, get to the udder of the cow and suckle the milk ourselves, because it will never make it to any international market. Remember, the EU is the biggest importer of dairy products in the world. Therefore, most of the standards, regulatory standards, are benchmarked on what the EU requirements are. So, sorry, we cannot import milk until we meet those three criteria: bacteria, somatic cell count, and antibiotic residue testing.
Thank you, Dr. Kamagi, for that response. Please, if you have any question to us, just raise your hand and we'll be able to unmute you so that you can ask your question. So to raise your hand, you just click on the list the participants button, and then there should be a button on raise hand. Or simply you can unmute yourself and then ask your question.
Another question, if there are no other questions, I hope I'm not closing anybody, then I can quickly address one or two of the things one or two of the items that you asked me to address from the last set of questions, and I'll try to be quick about it. Dr. Nazaria asked a question about, in relation, and this is the question, in relation to milk, what's the difference between milk quality and milk safety? Milk quality has to do with the regulatory standards and the components as a basis of payment. So two things about quality. Quality, when you're talking about quality in milk, you're talking about how are we going to pay our farmers? That's number one. And remember, from our lecture, we said there are various ways of paying the farmers. The components, and the components here are butterfat, protein, somatic cell count, those, and the volume of the milk. The farmers get paid according to the amount of milk they ship, according to the butterfat in the milk, the protein in the milk, and the somatic cell count. That is important. For regulatory purposes, I've kept on repeating, we have antibiotic, bacteria, and somatic cell count. That is quality. Safety, on the other hand, has to do with the nature, or rather, for lack of a better word, the cleanliness of the product that we are presenting, either at the farm level or at the product level when we are releasing it to the consumers. And that's where things like, yesterday I was giving a talk about food defense systems. One of the biggest things in our society today is bioterrorism. And milk companies are at a major threat of bioterrorism. So what do? They implement what is called a biodefense mechanism. So you have to go out and conduct what we call a food defense audit, look at the potential loopholes of bioterrorism or loopholes for insult that could present an opportunity for compromised safety. So that is what happens. And I hope that differentiates between quality and safety. The second question was from Dr. David Chemirmir, and he asked, in the pasteurization process, what's the temperature, what is the temperature the milk is cooled up to? Is the pasteurization cooling time limited as well? Good. And I have to correct myself from what I said last week. There are different types of pasteurization. The most common one is you take the milk and rapidly heat it. and then rapidly cool it. That's what pasteurization is. Rapid heating, rapid cooling. So in that heating, there are different levels. You can decide to go in for, you heat it to 63 degrees Celsius for 30 minutes, then you rapidly cool it. And the cooling temperature for any milk product is supposed to be between 0 and 4.5. If there's anything you have to remember today, is what is the temperature, required temperature of milk? 0.0 to 4.5 degrees Celsius. Don't forget that. So when you heat it and suddenly cool it, your aim of cooling is 0 to 4.5. Now, that is the normal pasteurization, 63 degrees Celsius. There is also what we call HTST, high temperature short time, in which case you can increase the temperature and make it 72 to 73 degrees Celsius. And you want to do that in 3 seconds, or you can do it in 15 seconds. It all depends with what you choose. But the whole idea about pasteurization is rapid heating, rapid cooling. And when you cool it, it has to come down to 0 to 4.5. So that answers Dr. Chemirmir's question. Dr. Yegon, he asked, what is the prevalence of illnesses associated with milk in the US? Now, I did mention that the bulk of contamination or infections that we get from unpasteurized milk today, not just in the US, but all over, is associated with campylobacteriosis as a result of Campylobacter jejuni. That is for raw milk. For the pasteurized products, the greatest infection rate comes from the norovirus. Now, we get a lot of milk infection prevalence in the US because of the norovirus infection, and that has resulted in a lot of callbacks. I can look for the actual statistical figures to give you. I don't have them at fingertips at this point. Had I known about that question, I could have done my homework well, but I can inbox you later on to give you the details. I'm almost done with this. Dr. Grace, Dr. Kamagi, tell us more about how you ended up in the US. Young vets need to hear about your story as a mentor to them. I'm right here. I came here in 2006. Dr. Sabuni is smiling. We used to, I came here in 2006. I had just started my master's at the animal production department, got done with my coursework, and an opportunity in the US opened up. They wanted a veterinarian. And I came over here and made a living. So I'm still here, how many years? From 2006 to now, 14 years down the line, I'm still out here. And I look forward to a time where I probably will come back home and utilize the experience and the knowledge gathered out here to be a useful resource back to our dairy industry. I have a deep, deep passion for the dairy industry, and I'd like to use this as a way of give back to the community. We can always go and side chat on this, on the actual details of how I ended up here. Like I said, Sabuni knows the details of that a little bit and how that happened. And thank you, Sabuni, for giving me a smile at hearing that. Dr. Kiunga, our treasurer, in regards to indigenous cattle milk, can it be recommended more than the exotic ones? I don't really think I'll be in a good position to make that sale right now and say our indigenous milk is worse than the exotic. What I do know is some of the exotic breeds, if you're going for things like butterfat and protein, some of the exotic breeds do have a higher milk, higher in concentration of butterfat and protein. It just depends with what the composition of milk you desire to get from that cow. And again, depends on your market. If you're getting milk and you want to produce this milk to a lactose intolerant population, then you want to get milk and then separate lactose from it. Chances are you are not going to get that from an exotic cow or an indigenous cow. It just depends on who your end user is and what you determine to get from that cow. But I don't really think I'll be in a much better position to give a clear side-to-side comparison between which one is better of the exotic or the indigenous breed. Dr. Leonida Osoro, I remember A great presentation, Dr. Kamagi. What is the contribution of genetic makeup in somatic cell count? I don't really think somatic cell count will be associated with genetics in any way. It has to do with the inflammatory process that goes on in the udder. You can have the best cow, a premium, solid genetic cow, and what happens if you mismanage that udder and expose that udder to situations that will infiltrate that mammary tissue to somatic cell counts or to inflammatory processes, then your somatic cell count is going to increase. So I think somatic cell count is more to do with the health of the cow than does the genetic aspect of it. Dr. Joyce, excellent presentation. I just want to inquire if you've ever tested antibiotics using HPLC technique. If yes, could you share? And if no, could you refer to those who've done it? Those that don't know HPLC, high performance liquid chromatography, that is the name of the test. You don't do HPLC for regulatory reasons. You can do that for research. I know in the US, HPLC has been used to detect adulteration of meat and milk using flunixin meglumine. That is a very, very common anti-inflammatory, non-steroidal anti-inflammatory drug that we veterinarians use in the US, especially for pain control and as an anti-inflammatory agent. It was used so much so that people were giving injections of, we call it Banamine, that is the trade name of Banamine, just IM, and they will not even do any milk withdrawal. According to the label on flunixin meglumine, the product that we use in the US should have at least 4 days of withhold for meat, actually 4 days for milk and around 11 days for meat. So we started having incidences of flunixin meglumine showing up in dairy products and meat products. And therefore, FDA required that meat plants start doing high performance liquid chromatography to detect flunixin meglumine levels. And again, they banned the use of flunixin meglumine for intramuscular injections. It's only used right now as an intravenous preparation. So no, we don't use it for regulatory purposes for milk, but yes, you can use it to detect other compounds that are volatile, and chromatography will be good enough for that. And flunixin is one of the drugs that has been detected using HPLC. Now, can I recommend it? Of course, yes, I can recommend it. But for what reason will you want to do that? How many times will the vet go out? What I normally tell people is if you can use an anti-inflammatory drug other than flunixin that will give you a milk withhold or a meat withhold that is so stringent, go ahead and use that, But as it stands right now, we only test for beta-lactamase inhibitors. That's what the regulation is, beta-lactamase inhibitors. In the recent past, they've started testing for tetracyclines using Delvo and the CHAM methods. But for regulatory purposes, the only set of drugs tested for, in terms of antibiotic residue testing, are the beta-lactamase inhibitors, the penicillins, and the derivatives like the cephalosporins. Perhaps the last one, no, actually the second last one, Godfrey, he asked, any test for dewormers in the milk? No, we don't do that. I don't know if anybody has any idea if they're done in Kenya, but we don't test for dewormers in the United States. And I've never heard of anybody testing for dewormers back at home. There are dewormers that require milk withhold, that one is for sure. And that's where a veterinarian's judicious use of drugs comes in. You need to be judicious. And right now I'm working on a document that probably if I get an opportunity to share with KVB and probably VMD on ways of trying to combat or regulating drug use by veterinarians. Because one of the biggest problems that we have right now is is quacks, having drugs, injecting cows all over. And I'm putting up a proposal that I want to share with the KVB once they get me off the hook, and the VMD, on how we can, work together to eliminate the very, very simple ways. I don't want to divulge the details over here, but if that goes through, I think it will be a game changer in creating jobs for veterinarians and animal health workers in Kenya. And it will also help us in antimicrobial resistance fight. The last thing, have you conducted any antibiotic residue using HPLC? I think I just answered that. Acaricide residues in milk using GC, which is gel chromatography. We don't do that for, remember, I come from a regulatory standpoint. I'm a regulator, or rather I was a regulator until I started my current job. My work is to make sure that that the farms comply to the regulatory standards. So we go by what we regulate. And in this case, like I said, we only regulate for beta-lactamase inhibitors. Any other question before we end this?
Any more questions? You can just unmute yourself and proceed to ask the question.
I'd love to hear something from Mumanyi. Mumanyi.
I can see there's some comments, Dr. Kamagi, from the chat also, what members actually are stating. You can just read them through for you. Some are saying around, these are great presentation. And then I think there was specific, especially from Dr. Alex Abuni, around what will cause freshly milk to coagulate at boiling. Other comments around a great presentation, Alex Kimeli, informative presentation from Samuel Maina. Liz also said, I should like to have the presentation since she joined late. I think also, Sabuni also mentioned around Israel pricing their milk, which is dictated based on the somatic cell count and butterfat content, which by the year 2017, it was around 3.7%. Other comments was from Kiplangat, said it's a great presentation. And then there was a comment also from Sabuni around that in terms of butterfat content, indigenous breeds are superior. However, looking at milk safety, a lot needs to be done about this. Nowadays, most processors are looking for milk from indigenous cattle, but sadly they bypass. They pay based on quantity rather than the quality. Yeah. And then there's also another comment by Sabuni around ivermectin. There's heavy ivermectin use among the pastoral communities. And this is a product to watch. For instance, imagine the quantity of milk for 30 straight days with ivermectin residues. Yeah, and then also reiterating the other question around what will cause freshly milk to coagulate at boiling. So back to you, Dr. Kamagi.
I'll start with the coagulation of milk. There are several factors that will interfere with the integrity of milk to the point of causing coagulation. One, the most common one is high somatic cell count, which is normally an indicator of subclinical mastitis. That is one major reason. And I've had farmers call me and they'll be like, Doc, I have this cow that is towards the end of her lactation. She's pregnant, probably 6-7 months pregnant. Anytime I get milk from that cow, it coagulates. And my answer is always one. Cows that are towards the end tail of their milk production cycle tend to have a much higher somatic cell count. Reason is they've already peaked and the milk production is naturally declining. And because of that decline in milk production, and you've continued milking this cow, what happens is that you are subjecting that udder to much more pressure to produce what it naturally cannot produce. So what happens is that you end up with inflammation. And what happens during inflammation? You have infiltration of inflammatory cells into the other tissue, and that reflects in higher somatic cell counts. And then we also have the physical aspect of it. You know, these cows have been milked for a very long time. Over time, that alone, that irritation to the other tissue with the time just leads to higher somatic cell count naturally. Because of that, you end up with aspects of higher somatic cell count. And like I said, somatic cell counts, if the cow is not sick, they are always indicators of subclinical mastitis. And that is one major cause of milk coagulation. Time and again, you'll always find that to be a cause. The other thing that is less likely, when people use equipment for boiling milk in their houses, sometimes you can find an equipment that was used to hold a product that has some acidity in it. And what that happens, the very moment you have milk in it, you end up with curdling. So that might also do it. The equipment, and most times it has to do with higher somatic cell count. And there is a point you raised, Momani. The biggest problem we have right now, and that was one fundamental reason why I thought of coming up with this block of lectures, and I'll try to build this and add a few other things with time. And I have a passion of having each and every one of you that is looking at me today transforming the dairy sector in such a fundamental way in whatever niche we have carved. Rolex, wherever you are, outside the country, me, wherever I am, Dr. Abraham Sangura, using our niche to affect the dairy industry in a positive way. And the reason for that is there is a lot of money that is tied to the dairy industry, both in terms of what is bought and in terms of what the farmers are paid. My main concern is a lot of dairies cannot stay in business for a long time. And one of the reasons for that is we have a single vendor system where somebody comes in, he's the monopoly, he picks the milk, and you have no choice. You take what he pays you. And we had representatives from the Kenya Dairy Board last time, and we started that discussion with them. I'm glad they were here and they shared with us that it has come to the point where the KEDB is starting to put up regulations, and they're going to say, these are the standards. If you get milk, not only are you going to pay this farmer according to the amount of milk he's shipped to you, but we are going to pay them according to the quality. And that is good. The reason being, it is a healthy way of introducing competition in the market. Because if you don't, imagine if all of us went into, right now we are talking about US presidential elections and being politically right, I don't know your political affiliations, but you introduce competition to get the best. So what happens is that if there is no basis upon which you can tell the farmer, yes, we're gonna pay you for the 400 pounds of milk that you ship, but guess what? If you ship 400 pounds of milk, and in addition to that, that milk is low in bacteria, we are going to give you 10 shillings more for every pound. And in addition to that, guess what? If you have superior protein, we are going to pay you another 5 shillings more to what you are producing on top of that volume. And on top of that, if you produce superior butterfat, we will give you another, 2 shillings more. At the end of the day, for that same 400 pounds or 400 liters, that farmer is not only getting paid for the amount of milk, but is getting paid for the quality. That will make him go back and want to get this extra marupurupu on top of the base payment for quality. And how can we do that? You cannot tell him that I'm going to pay you for butterfat. Then you're like, on what basis are you going to be? That if you ship the milk and it is 3.7, then we're going to pay you 20 shillings more. On what basis are you deciding that 3.7? There has to be a standard. We have to set that standard. And that's how we have to start this conversation. We must stop selling the milk from the farmers on the basis of volume because we are killing these farmers. We are killing these farmers. They are our employers. And these big companies know it. They don't want the issue of quality because if you standardize and regulate the milk industry, they are going to be forced to pay the farmers for what they want. The farmers are going to increase their herd sizes, and that is employment for you and me as veterinarians. So we have to look at this from an employment standpoint. And if the milk industry can be reformed, nobody will graduate from vet school, trust me. Nobody will graduate from vet school and have nothing to do. Nobody will graduate from an animal health training facility and have nothing to do because people will diversify into being large animal veterinarians, dairy veterinarians. Others will go into inspection. The Kenya Dairy Board will have inspectors. Others will go into, say, teaching what I'm teaching today. So we have, the dairy industry has a potential. We have to capitalize on it. But more so, I think the farmers are getting disenfranchised and it is not fair. It is killing the dairy industry.
Thank you, Dr. Henry, for that. I can see
that was a good, I said that with a passion like I was preaching. I almost made an altar call after that.
That's good. So I can see a hand from Dr. George. Owino, please proceed and ask your question.
Kamagi said, most of the smallholder systems in Africa are actually being pulled back, especially the farmers. Most of the processors are actually paying money according to volumes. They're not looking at the quality of milk. If you look at Zimbabwe as a country, there was a time Zimbabwe was paying milk according to quality when the white farmers were there, most of the white on farms, the large big farms there, and they used to get premium from the milk that was being sold. But at the current state, nobody is paying them according to the premium quality of milk. It's more about volume rather than the quality of milk that is being sold. And the same applies to a few other African countries that are doing are into dairy production. I don't know, Kenya the same, but in Kenya at least you find that some processors are actually paying according to quality. For example, the biomilk, they actually look at quality. So we are hoping like-minded people, especially the vets around, and also those people who are graduating out and there, and also the veterinarians who are still at home can look at it at the point of view Kamagi is putting, whereby we not only focus on vets being people who cut and close animals, but we need to look at ways to promote this industry so that we can create jobs for our own. We can be inspectors, like Kamagi said. We can be people who are specialized in large animal practice, like some of us are. We can be people specialized in milk quality and things like that. So it's all about us putting all these things in place so that we can create opportunities on our own. Thank you so much, Dr. Kamagi. And I think we will be having a side chat and trying to look for ways forward in which we can be able to strategize and promote dairy production in Africa in general.
Oh, thank you so much. You mentioned Zimbabwe, and I was like, oh my God, because they were paying on the basis of quality. Then the white person left. Then they started paying in terms of volume, and I was like, maybe they need to be colonized again. I'm sorry. I'm saying that knowing very well that my wife is Zimbabwean, so she's still asleep. So I'm very safe. But if my video suddenly disappears, just know that there is domestic violence going on. I just said it. I'm just throwing out there for the birds of the air to know, just in case something happens, you know how to trace me. But you are absolutely right. You said there are companies that pay on the basis of quality, but you know where my problem is? Those quality standards, they're paying in terms of quality, but who sets those standards? They set them themselves. But tell me, if you are a businessman and you are going to pay somebody for a premium, and you are the one setting the levels that you are paying him on, you are like, okay, 3.7 is bad quality, I'm not going to pay you anything. 3.72 is good quality. Who sets this standard? There has to be a regulator that sets the baseline standards. So what I'm saying is, it doesn't matter what individual companies are doing out there. If this can be a policy issue, and it is set by, say, Kenya Dairy Board or say the Kenya Bureau of Standards, and they say, if a farmer produces milk that has butterfat 3.5, You have no choice, but you have to pay him quality. It's not you to decide. It's not you to decide how much quality is. We already have those standards, and that's what we are going to use. And when it comes to quality, a regulator has to set that price, because people that buy milk will always want to pay less for business reasons. And that's how we are killing these farmers, because we've left them in the hands of people who are just killing them. Violence? Okay. So you're absolutely right. And there's somebody that asked a question. Dr. Sangula touched something. I'd like to respond to Dr. Sangula. In fact, this is the easiest way to motivate the small-scale farmers. Currently, on the large-scale farmers benefit from this volume-based payment method. Attempts to pull small-scale farmers through coverage isn't helping because of mismanagement. Absolutely right. If we start paying by quality, it will put a level playing field for the small-scale farmer and the large-scale farmer, because the small-scale farmer that cannot get money because of his low volume, at least will get something because of his quality. This is the game changer in the dairy industry, guys. This should be the game changer in the dairy industry. If there is anything any of you can do in any manner, let's start focusing on lobbying to have these regulatory standards for quality rolled out. This is the only way we are going to help our dairy industry. Otherwise, if we leave them at the mercy and the slaughterhouses of these large dairy companies, they're going to be slaughtered for sure. All right.
Very good. Very good. Thank you so much, Dr. Kamagi, for that wonderful presentation. Looking at the chat and also looking at the participants, there is no other hand up. It simply means actually all members are contented. And I think a key take-home message and an action point is actually to lobby for farmers to be paid based on quality rather than on the quantity. At this opportunity, I think I would like to give one member from the team to just give a vote of thanks. Any volunteer? I can see, I would like to volunteer Dr. Marilyn Karani to give a vote of thanks, then we can close the session.
Just before Marilyn goes in, and the passion I have for this, if it gets to the point where I have to come home and help share this with people of like minds, that's a trip I'm willing to make. I'll make that trip. Easy, easy. So Marilyn Kamani, you know, I almost said Kamagi. Marilyn Karani, go ahead.
Hello?
Hi, Doc, we can hear you now.
Hello, sorry, I was logged off kidogo. I think on behalf of the participants of this meeting, I want to take this opportunity to thank Dr. Henry for finding time to share with us this very important topic. We know that in most cases, people will be charging for this, and we've been able to attend freely. And for that, we thank you very much. And we pray that you continue to, bring more information so that it can transform this country. And I also want to take the opportunity to thank all the participants. I realized we were about 36, 38, and I hope that in the future we can be many more so that we can make the change that is needed. Thank you very much, everyone, and have a happy Sabbath.
Thank you so much. Happy Sabbath too.
Special thanks to Dr. Kita, Daktari. It is humbling to see my teacher and Dr. Kita. Many of us have passed through the hands of Daktari, and Doc, I really feel honored and privileged to have you sit on the other side after so many years. Thank you so much. The kind of things you instilled in us, up to and including the laughters and the jokes, are still with us today, as you can see. And even the passion for Subarus, for those that have Subarus.
Okay. Bye-bye, everyone. You'll receive a copy of the recording to your email.
Somebody is having a quick question. Hello, did you respond to my question? She was asking what was the question again? Can you conduct antibiotic tests at the farm level? Is that a question?
Yes.
Can you test for antibiotics at farm level? Yes. The SNAP test is a test that can be done at the farm level. It is a 10-minute test. So IDEX sells it. It comes with instructions. You can do it. Thank you.
Thank you, John.
Bye.
Bye-bye.
Bye.
Bye, guys. Have a nice time. Thanks for attending.
You too.
Yeah.
Bye. Thank you.
Thank you. That was so informative. Thank you.
Thank you, Dr. Sabo.